Thanks for joining the meetup today. And today it's a very special day, right? You know, JavaScript was released 25 years before. Happy 25th birthday to the world's most successful and most misunderstood programming language. Before we actually kickstart the event, let me do some housekeeping announcement. Yes, NG Sri Lanka is one of the great initiative that we started last year, and we had a great success with the inaugural event. And thanks for the amazing support from everyone. We wanted to do this event in a great manner, but unfortunately, we are facing some challenges as others. Due to the overwhelming support and the request, we decided to do something different. And we came up with a series of meetups, which we will be doing in the coming months. And you can expect the conference soon. First of all, thanks for the amazing feedback over the period of last 12 months. There were requests for volunteering, requests to be a speaker, and for the conference itself. Yes, on the today's meetup, today we have a really special guest. Let me introduce her to everyone. It's none other than Deborah Kurtana. Personally, I have known her for the past 5 years or so. She has been my inspiration to become a GDE and MVP. As I said before, I learned Angular concepts through her Pluralsight course, and I'm sure that it will be the same with most of you. To those who don't know her, she is a developer, consultant, a conference speaker, and a Pluralsight author. Her courses include Angular Getting Started, Angular Routing, and then today one of the topic that she will be covering, RXJS, and also reactive development. For her, her work is usually supporting other fellow software developers. She has been recognized with most valuable professional by Microsoft Tower, and also she's a Google developer expert on Angular. And today's topic, she will be very much, today she will be covering one of the important topic for not only Angular developers, but for JavaScript developers as well. Yes, it's RxJS. Today she will be talking about some of the important terms, tips for developers, and techniques with reactive programming. For those who are watching, keep asking your questions, keep posting your questions on the YouTube channel. We will be picking them at the end. Without further ado, let me hand it over to Deborah now. Deborah, stage is yours. You can share the screen. Thank you.
Thank you. All right. Well, he already introduced me, so I don't need to do this part. Thank you very much. I appreciate it. So we're going to jump right in with some terms. Starting with the key term when you're talking about RxJS, and that's what an observable is. You can think of an observable as a collection of items over time. So it's not a collection like an array because it doesn't retain items like an array does. It emits items that can be observed over time. So let's look at a little example. So here you have an array, and you can get the third character out of that array. Sometime later on a different part of your UI, you could get the fourth character out of that array, and that array retains those items and you can work with them. An observable, however, is more like that. There's the A, there's the P, and so they're coming over time. They're not held in a unit like an array is. You can almost think of an observable like a drive-up window. So I don't know about you there, but here it's not safe, I guess. I hate to use that word, but it's not very good practice to be going into restaurants. And so we're using the drive-up window. And so you can think of an observable sort of like a drive-up window where the person at the window emits food items over time. And if you come back around to try to pick up something again, well, it's not there anymore because that person already gave it to you. So you can kind of think of an observable that way. No metaphor is perfect, but that one sort of works. Okay, so why? Why would we want to use an observable? What's the big deal with RxJS? Well, when you're using a web UI, when your users are actually working with an application, there are a lot of things that arrive over time, right? Their key presses arrive over time. They don't happen all at once. They happen over time. Mouse movements happen over time. Button clicks, selections off of drop-down lists, all of those happen over time. HTTP responses. So if you go hit a back end server and it's going to give you a response, that's happening over time. And observables work well with data over time. Observables also help provide notifications. They give us process complete notifications and failure notifications. So the observable and RxJS in general help us react to the arrival, or in RxJS terms, emissions, and those notifications. So as things arrive over time, we can react to them. And that's why it's referred to as reactive programming. What does an observable then do? Well, it does nothing until a consumer subscribes. So until somebody is listening for these events, it's not going to do anything. When subscribed, the observable begins emitting items or notifications to the consumer. There are three kinds of things that it can emit. It can emit next, which then contains with it as part of its payload the next item, whatever that is, that A or that P. It could emit an error, and then its payload is what the error is. Or it can emit a complete, and it has no payload. It's just, hey, it's complete. No more items are then emitted and processed. Okay, so those three. That's what an observable does, just those three things. All right, so throughout this talk, I just have some tips intermingled. The first tip is that marble diagrams can sometimes aid in visualizing an observable. So if you go to the documentation under for RxJS, you'll see that a lot of the documentation includes marble diagrams. Now, I do overly simplified marble diagrams, kind of stylistic and simplistic, and we'll see what a more quote unquote real marble diagram looks like in a few minutes. But you can think of this one as an example HTTP request. I call them one and done because when you issue an HTTP request, it comes back with one and only one HTTP response. So when you have an observable that is based on an HTTP request, you will get just that response back. So in this case, our request was for product data. Our response back was that product data. So it's called a marble diagram because that purple thing sort of looks like a marble. The vertical line represents complete. So it's one emission and then complete. Looking at another marble diagram, this one would be more infinite, say for the user typing stuff. So each of those green things is a marble. So the A happens, a person's a really slow typer, a P happens, and then another P happens, and so on. So you'll see these throughout this talk and through any of my talks or courses. You'll see marble diagrams that look simplistic like this. So I'm an Angular developer, so I look at observables through an Angular viewpoint. And with Angular, it automatically creates observables for us. For example, routing emits parameters via the param map observable. So you can then watch for changes to your parameters. So say, for example, you're on a page that's showing a single item, item number 1, and it has an arrow that then shows item number 2, item number 3, as you're doing next through the page. And what is happening is your route is changing. So it's showing you product/1, product/2, and the Angular creates an observable that's actually providing you notifications of those changes. The value changes is another example for forms. So as the user is modifying anything in a form, you can get value changes observable. The most common one, though, is the one I mentioned a few moments ago. The HTTP client emits the response via an observable. So let's look at the code for that one. So here's our code. So we've got a get products method, and it returns an observable, and its generic parameter there is defining what that observable is going to emit on a next, and that is our array of products. So it says product array there. And then we're returning this .http get, so that's the Angular HTTP client get method. And again, we're telling it what kind of data we want it to map that result into. And again, we want an array of products, and we give it the URL. And so we don't have to create an observable. It's going to create one automatically. We don't have to next anything into that observable. It will automatically do that when the response to that HTTP request comes. So this would be in a service by convention, and in your component, you would have an ng on init where you're calling that service. Okay, so for those of you with experience with this kind of stuff, I have the YouTube chat up. Anybody want to tell me what this code does in 3 words or less? Anybody want to take a shot at it? The correct answer is nothing. Why does this code do nothing? Do you remember what we said about observables? I asked earlier, I stated earlier, what does an observable do? And I said that it does nothing, right? It does nothing. There you go. Got a bunch of nothings out there. I think there might be just a delay in getting your answers over to me. All right, so why does it do nothing? It does nothing because nothing is subscribed to this. We have no subscribe in here. So an observable does nothing until the consumer subscribes. So you can think of a subscription like the old days when you couldn't get a newspaper unless you had someone deliver it for you. Or you could think of it, I guess, more relevant to these days, an online newsletter. You won't get a newsletter unless you've subscribed. Or like YouTube, you won't get notifications of people adding to their YouTube channels unless you've subscribed to that channel. So that's kind of like a subscription. Technically speaking, though, a subscription in RxJS world is an object that represents the execution of an observable. So you use the term subscribe to subscribe to an observable. So here we're subscribing to the one we're getting back from the get products method. But if we want to hold on to that subscription, we need a variable. So we're going to put it into this .sub, short for subscription, and that's going to hold our subscription. Why do we want to do that? Comes our next tip. We want to ensure each observable is subscribed and each subscription is unsubscribed. So our code would really need to look more like this. So our component would look similar to this, where we're going to implement on init and on destroy. In our on init, we are subscribing, so we get our data when the page appears. On destroy, we're releasing our subscription. We're unsubscribing. Okay. So there's our subscribe, there's our variable, and there's our unsubscribe. However, if you look at this code again, we're still not really doing anything because we have our products array defined in the second line there, but we're not populating that. How do we work with that emitted value? How do we get that out of the subscribe? And that's where our third and last term comes from observer. Our observer watches for emissions and notifications. What notifications? Okay, what did I say that an observer, what kind of notifications does it provide? Do you remember? We've got next, error, and complete. So those are the 3 notifications that our observer is going to watch for, because those are the 3 notifications that an observable emits. Okay, so how do we define an observer? Well, we can't explicitly create an observer, though this is uncommon. I can't say I've ever seen this in real code, but I wanted to show it to show that it is actually an object that you can define. So this is defining an object. This is kind of straight up JavaScript code where I'm creating an observer and I'm setting it equal to an object. And that object has 3 functions. The first is a next function. Its parameter is the emitted item. In this example, it's an apple. The error is the next function. It has as its parameter the error, and then complete has no parameter. And so those are your standard arrow functions that are defining those three functions for the observer. Then you would pass that observer in to the subscribe method. But that's not normally what we do. Normally, what we do is we simply pass into this subscribe our functions. However, they're recently making a change to subscribe where it only allows you to pass in one thing. So you can either pass in one function, which is our next function. So if that's all you need, you can do that. But in most cases, you also want to handle errors. So if you need to be able to handle errors, the one thing you pass it is the whole observer object. So here again, we've got our curly braces defining an object with three functions. Okay, now if you're not a big fan of arrow functions, you can also use the same syntax with function declarations. So here is that same code, and we're using more the standard function syntax, where it's the next function where apple is our parameter, and then we've got a function body defined with curly braces. If you go with this function declaration syntax instead of the arrow functions, though, you need to watch out for this, because if you did something like this code next to the big red X, it's saying this dot apple equals apple. That is not going to modify our class level variable. It is instead going to modify a new variable that it's going to define at the function level. When we use function declarations, any variables we declare or define in there are going to be scoped to that function and not reference class level variables. Okay. So in summary, our observable is our source of our data. The $ on there is a convention that a lot of people use to identify that as an observable, so you know that you are going to be getting emitted items from it. Our subscription is what we're assigning it to on the left there, and our unsubscribe then is done on that subscription variable, and our observer is the thing that we pass into the subscribe. So those are our terms. Here's a simplified marble diagram showing 3 emissions and complete. The line is representing the observable, the marbles are the emissions, and there's our complete. All right, so I had said I would provide one example of what real marble diagrams look like, and this is an example of one. This is from Michael Hadlicki, who is also a Google GDE, and he is working on some really nice, complex, completely technically accurate marble diagrams. There's one of them. Okay. So our terms, we covered observable, subscription, and observer. Let's move on then to techniques. So how are we going to actually use RxJS? One of the techniques is that RxJS supports the idea of a pipe. As your emitted items flow through the pipe, it transforms them. So for example, we might have an A and we're going to define a lowercase operator in our pipe. And so it's going to make our emitted item lowercase, and then maybe an enlarge operator, which will make it bigger. So that's just a simple example. Some common RxJS operators are tap, which taps into the stream without modifying it. You use that frequently in order to do debugging things or side effects that don't really affect the stream. Map is a basic transformation, and catch error catches errors. Okay, these are 3, but there are about 100 more. So we're not going to obviously cover them all here, but I am going to cover a few more as we go through. We're going to cover combination operators, a couple of them, and some higher order mapping operators. But we'll start with these 3. So a common usage, you start the stream with a subscribe. It starts emitting items into the stream. You pipe those emitted items through a set of operations. As an observer, the code processes next, error, and complete. And then you stop the stream with an unsubscribe. All right, so using a pipe. So there we're starting the stream with our subscribe. Here we're piping it through a set of operations. We're doing a tap to just do some debugging. We're going to log what that apple is that we're getting. Then we're doing a transform with a map. We're taking that app and adding it to a juicer. And then what we get out in our subscribe is actually juice. And so we're going to console log that. And then we stop the stream when we're done. So that's a very common flow. All right, so our next technique is retrieving data. And I put up this slide just to ensure we were all on the same page here of how retrieving works on the web. So we have our web browser over there on the left, our web server on the right. We issue an HTTP request. So here we're going for products with an ID of 5, and then that's gone. And at some later point in time, because remember, observables are data over time, then it finally finishes retrieving that data and giving us back the response. Okay, so what does the code look like? Well, retrieving the data in the service looks very similar to the code we looked at before, but now we're doing the piping. So here of our set of 4 steps, we're doing the second one, piping them through. So we've got our tap to do some debugging and catch error to handle any errors. What about the other 3 steps? Well, we're going to do those in the component. So here again is our component. We looked at this before. All that we've added now is our observer next method, our arrow function in there. So we're going to start the stream with our subscribe. We're going to process emitted items. We only have the next function there, and we stop the stream with the unsubscribe. All right. That is considered a procedural approach to RxJS. What do I mean by procedural? The idea of procedural is that we're creating and calling functions, and the function returns an observable. Instead of a procedural approach, we can use a declarative approach. In the declarative approach, we declare a variable, and the variable references are observable. So a procedural approach versus a declarative approach. Most of the documentation, most of the beginner content covers the procedural approach because it's a little bit more straightforward. But the declarative approach is significantly more powerful because you can work with these streams much more easily instead of calling functions. Let's look at an example. So here's our service as we had it in our last slide. So instead of having it a procedure, we instead declare a variable. So here's our declarative approach. So you notice that there's very little difference. We're just defining a variable instead of defining a method. Then in our component, instead of all of this code, we simply, which is procedural, we're calling our method, we simply use our declared products from our service and declare again a variable. But wait a minute, what about the subscribing and unsubscribing? What happened to that? What's going on with this? Well, one of the other nice things about using a declarative approach is that you can then use the async pipe. Now, it's sometimes confusing, especially if you're a little bit newer to Angular, that the async pipe and the RxJS pipe are 2 totally different things. The RxJS pipe is a way to pipe emitted items. The async pipe is something to do with your template. And it's another kind of pipe, just like your date pipe and your numeric pipe and your lowercase pipe and so on. So the async pipe is literally that pipe character that you see. So we've got products $pipe async. And what that does is it lets our template work directly with a variable defined as an observable. So you see our $sign there. We're telling it that that's an observable and it needs to use async. The as product there is telling it when it emits a value to emit it into that variable. So this products dollar is going to retrieve all the products dash async. What the async will do is automatically subscribe, automatically unsubscribe, so that we don't have to do that part. And it puts the emitted item into the products that we can then use later in our template. So this is our declarative data access pattern, where we've got our products that we're retrieving in the service, which is the bottom part. The middle part is our component. I've tried to color code these. So the purple are the service, the blue is the component, and the green is the UI. So what this allows us to do then is work with our observables much more declaratively. As you're working with more complex observables, which you can do more easily once you've used a declarative approach, here's a tip for how to work with them. Think about what do you have, what do you want, and when do you want it? Those three questions will help you attack how to do an observable. And I just noticed a question about how you use RxJS with WebSockets. There is an actual RxJS WebSocket API. So if you find that library, if you want to reach out to me on Twitter, I'll look it up for you. I'll give you my Twitter address at the end. But there is an RxJS library specifically for WebSockets. Okay, sample application. So here's our sample application. We've got our list of data. But say that we have way too many products. We have way more products than we want to display all at once. So we want to instead have the user pick a category. Okay, so we've got something more complex here. What are we going to do? Let's think about our questions. Start with what do we have? What do we have? Well, we have that interaction that the user is going to have of clicking on one of the categories. And we're going to have that over time, which right away tells you, hey, we probably want an observable because the user is going to potentially pick different ones over time. What do we want? Well, we want then the list of products for that category. When do we want it? Every time they change what they've picked for their category. Now, this is where it gets complicated, because if we just did a procedural approach, we could simply pass the category ID in. But now that we're declarative, how do we get that? I mean, this code as it's written isn't going to work because we don't have a category ID unless we did a global variable, which, because everything it could be async, could be just a mess. So how do we deal with that? To respond to an action, use a subject or behavior subject. Now, I mentioned earlier that Angular creates observables for us with an HTTP response, with value changes, forms, and so on. But we can create our own, and that's the purpose of a subject or behavior subject. We can create our own to respond to these actions over time. So here is what a subject and behavior subject, what the common pattern looks like. We use the new keyword to create a new subject. We use the generic parameter, the thing in this pointy braces, to define what we're expecting that observable to emit. And in our case, we want the category ID, which is a number. We're making that private because we don't want any other part of the code to touch that subject. We don't want it to be able to complete it. We don't want it to, any other code to be able to emit items into it. We want this to be owned by our service. But we do want other bits of the code to be able to subscribe to it or to be able to work with it. So what we do is we then use as observable to provide the read-only version of that, and that you can subscribe to, that your UI can subscribe to in your template with an async pipe. So I talked about subject and behavior subject. Behavior subject is just another kind of subject where behavior subject has a value that it always gives you. When a component subscribes to a subject, it won't get anything emitted to it until the subject emits the next time. when a component subscribes to a behavior subject, they will get the last emitted value, which is sometimes useful if you think that a component might be joining you late and they won't need the last value. Now, if it hasn't yet emitted anything, it has a default value, which is what its constructor parameter is, the 1 in there. Now, for our purposes, we don't want to pick any kind of category, have any default category. We want to wait till the user picked something. So we want a subject. So there's our subject. Now, also in our need to actually next something into there, we need to have that next emission. And even though our, and since our category subject is private, this code needs to also be in the same service that defined the subject. The function itself, though, is public. So as the user is picking a different category, the component can call the selected category changed and emit that category into the stream. But the service controls that. Okay, so now we've got a subject that is going to be emitting our categories every time a user picks a new one. So what do we have now? We have our category ID. So I call this pattern a retrieve on action pattern because we have an action and what we want to do is a retrieve. So we're taking our category selected action and we're piping it through a set of operators. But maybe we're not quite sure what kind of map operator to use there. And also notice that we now have an observable, which is our category selected action $. That's an observable. And we also have a second, what's called an inner observable. So if our UI, if our component references this products $, and our UI subscribes to it via an async pipe, it will subscribe to this products $, here. It will subscribe to the category selected action $, but what's going to subscribe to that inner observable? This code is never going to do anything. So what do we do? How do we make this work? Well, that brings up another tip. Leverage your IDE. If you just hover over products, let's say you try, okay, let's try a map and see if that would work. If you hovered over products, you don't even need to run. You just hover over it in your IDE like Visual Studio or VS Code, which is what this one is. You can see that it's returning an observable of product. That's because category selected action is an observable and it's going to be emitting the result of that observable, which is an observable of product array. So you end up with an observable of product array, which isn't what you want at all. You want an observable of product array. So you need to flatten that. So we have two issues. We have an observable that needs to be flattened, and we have this inner observable that needs to be subscribed. So how do we deal with that? To subscribe to an inner observable and flatten the result, use a higher order mapping operator. These are sometimes called flattening operators. All right, higher order mapping operators. They automatically subscribe to the inner observable for us, so we don't have to deal with that. They flatten the resulting observable. So they return an observable of the type, not observable of the type, which is difficult to deal with. They also automatically unsubscribe. So they're magical. They're wonderful to have. So let's look at three of them. Switch map stops the current operation and performs the new operation. And if those words don't mean anything, we're going to talk through examples of all three of these in just a couple minutes. Concat map performs each operation one at a time in order, and merge map performs each operation concurrently. And again, we'll talk through an example because these words sometimes are simple words, but complicated conceptually. All right, so we're going back to our retrieve on action pattern. So here, what we have is we have our category that the user picked, and what we're going to use is a switch map here. Because it's a higher order mapping operator, it will automatically subscribe to our inner observable, and it will flatten the result. Now, let's talk through our examples. Why do we use switch map here? What switch map will do is it will cancel any ongoing request when it gets a new one. So say, users are users. So they pick category 1, no 3, no 2. We don't want it to get 1 and then 3 and then 2. We want it to cancel 1, cancel 3, and just go and get 2. And that's what a switch map will do. The user picks 1, it starts getting 1. User goes no 3, it cancels that and goes to start to get 3. No 2, it'll cancel 3 and start to get 2. If we used concat map, what it will do if the user said 1, no 3, no 2, it will get 1. Once 1 comes back, it will get 3. Once 3 comes back, it will get 2. So that would be kind of confusing for the user, especially if it takes a while because they picked category 1, category 3, category 2, and then all of a sudden they get category 1 data. And if they're patient, they'll get category 3 data, and so on. So in this case, that could be confusing. Now, the third one we talked about was merge map. What merge map will do is fire them all at once. So if the user did 1, no 3, no 2, it will fire off, get me 1, get me the ones for category 1, get me the ones for category 3, get me the ones for category 2. The problem with concat map in this example is that order is not retained. So depending upon how it's hitting the server, it could actually retrieve categories 1's last, which would be the ones that the user would end up seeing. So they could have a mismatch on what they picked and what they see. So you need to be careful when using that. Concat map, which is the one that goes 1 at a time, is best to use when you're going to do any kind of CRUD, create, update, delete operations, because they are ordered and you ensure that those are done successfully. All right, so if we went back to our IDE and hovered over with switch map, if we hovered over now products dollar, we would see that it correctly flattened it to observable of product array, not observable of product array. All right, so here's my simplified marble diagram. The user picks category of 42, it does the switch map and brings you back the products. If at some later point in time they pick a different category, it will bring back those products. All right, so that's the retrieve on action pattern. And you can see why for beginner content, frequently the procedural approach is easier because you just simply pass it in. But this is significantly more powerful. All right, so shape on action is another pattern. So for this pattern, what it's going to do is not do a retrieve because you already have the data. It's going to shape that data. So we're going to look at this pattern. In this particular case, what we want is when the user picks a product on the left, we want to display the product on the right. We already have the data, so we just need to filter it to find the one that's the hammer. All right, so we start again with our questions. What do we have? Well, we have the set of products. What do we want? We want the one product that the user selected. We want to show its data. When do we want it? Anytime the user picks a different product from the left. Okay, so we start, here is our products again that we already talked through. So this is how we're getting our whole list of products by category. That UI didn't show the category on it, but you can imagine that there was a category there. So that's what we have. We have our products. What we want then is to react to an action. So we know from what we just talked about that we probably need a subject or behavior subject. In this case, again, we do not have a need to display a default. We want to wait till the user picks one to show one. So we'll just use a subject and not a behavior subject. So this code is following that same pattern of defining a private subject and then a public observable from that. So we have got our list of products. We have got our product selected subject. How do we work with those two streams together? To work with multiple streams, we use a combination operator. Combination operators include combine latest. So I'm going to talk about 3 of them. Combine latest emits a combined value when any of the combined observables emit, and it won't emit until all observables have emitted at least once. Now that sounds like a bunch of gobbledygook, especially as late as it is where you guys all are. But basically what this means is if I am getting data from multiple sources, say I'm combining a stream coming from one endpoint that is getting customers and another one that's getting orders, we don't want to try to combine those until we have both of them. So what combine latest does is it won't continue in its pipeline until it emits both of them at least once. So that means it will wait to retrieve the people, it will wait to retrieve the orders, and then it can process them through its pipeline. So the combine latest operator is really useful if you want the process to wait till all the data is collected before it continues on through its piped set of operations. Merge emits the one value when any of its observables emit. Merge is really meant to combine things of like types. You wouldn't really use merge to merge a list of customers and their orders. Rather, you would use it to merge a set of customers from one endpoint that are overdue customers and customers from another endpoint that are active customers, and you want to merge them together, but they're all of type customer. So usually you use merge when dealing with like things. And then lastly is fork join. There are more combination operators. These are just the 3 I'm covering. With fork join, when an operator completes, it emits the last value from each observable into an array. So fork join is similar to combine latest. The key difference, though, with fork join is it won't do its pipeline at all until everything is finished. So you never want to use a fork join with an action that could continue, because that action will keep going like a value changed or a user selection. You know, like in our examples, we had, hold on. I made some tea this morning. In our example, we have the user picking one of the products. Well, that is not going to complete. And so if I used a fork join, it would never emit anything because it's waiting for all of the observables to complete. So in our case, we want to use combine latest. So here's our products. Here is our selected action, and we want to shape the products based on that action. So we use combine latest. All right. So our combine latest is combining the 2 streams, and then we can work with those streams to find the particular one that we want to work with. Here's a marble diagram. So we've got our data stream, our action stream. The user picks product 1 and gets the saw, picks product 3 and gets the axe, because it will continue to execute that as the action changes. All right, the last pattern then that I want to cover is the retrieve related data pattern. And in this one, we have our hammer, and we want to show its supplier. So in our product data, we have the ID of the supplier. So we need to wait to get that product, get the ID out of that product, use that ID to get another set of data. So this is a very common thing. The user logs in, you take their ID and password to go get the user record. In the user record, you use that user ID to go get the user's preferences or the user's orders or the user's whatever data. So this is a very common pattern, retrieving related data. So again, we're going to ask ourselves, what do we have? Well, we have the product. What do we want? We want its related supplier. When do we want it? Anytime the user clicks on another product. All right, so here's our selected product. We've talked about this one before. And here would be our product supplier. So what do we have? We have the selected product, so that's the one we're using. we're piping through. We've got an inner observable here, so we need to use a higher order mapping operator so that it will flatten it. Otherwise, we'll end up with an observable of supplier. So we switch map on it to get the data. What you don't want to have, and what is considered an anti-pattern, which is a technique that you don't want to use, is you don't want to have a subscribe within a subscribe. So instead you do a switch map, which handles the subscription automatically. Okay, so looking at this from a stream point of view, a marble diagram, we've got our product stream, and the user picked Axe on the left. It's going to switch map to find the supplier, Sherpy, and that is going to result in the stream. If the user picks another product, it's going to issue another request for that supplier and return that data. All right, so we covered some RxJS terms. We covered observable, which is a collection of items over time. Subscription, an object that represents the execution of an observable. An observer, which watches for emissions and notifications, next errand complete. We looked at pipe, async pipe, and some patterns, which include declarative data access, retrieving on action. The retrieve on action, we use that as an example of picking a category, but you could use it for paging. The user wanted the next page of data. You could use it for any kind of action like that. Shaping on action implies you already have some data and you want to filter, map it, or transform it in some way. And retrieving related data pattern is the last one that we covered. With that, here is my Twitter, so you can reach out to me on there. I've got 2 GitHub examples. This last one here, what I did is I took the tour of heroes. If you've looked at the Angular documentation at all at Angular.io, it uses Tour of Heroes as an example to walk through. It has a lot of walkthrough, hands-on kind of examples that you can do in the docs. I took that example and converted it to a declarative approach with all of its RxJS. So that also includes CRUD operations. So if you want to see how to do create, update, delete using a declarative approach, that's in that code as well. And with that, that's the end of my talk. Thank you so much for staying up with me so late this evening. I appreciate it.
I think you are on time. Thanks a lot, Deborah, for the wonderful session with a lot of insights and each concepts, right? I'm sure everyone would have got the most out of it. We could see from the engaging comments. I hope you picked up most of the questions, but we can take further questions if there are any. Host, can you highlight some of the questions? Yeah, there's a question on what is the difference between observable and a promise?
A promise is something that emits and then completes. It doesn't have the ability to continue like our actions. So you could do something like our data retrieval, which is one and done, but anything that would be responding to constant actions, you can't do as easily with a promise because each promise resolves and completes, and then that's it. It can't continue to take on emitted items.
Yeah, okay.
I think somebody kind of also answered that, but you can use observable. Yeah.
Yep. The next question is for an HTTP request. Since it's one time, why can't we simply use async await?
Well, hopefully, as you saw the rest of the talk, that was made more clear, because if you use async and await, then you have the data and you can't use it in any more pipelines. So if you noticed as we went through the talk, we took that same observable that we had used to get the products and we used it for the filtering for the action. We used it for working with that next pattern where we went to get related data. So by working with everything as observables, you have much more flexibility, because as soon as you use promises, as soon as you do async await, then you have the data. You no longer have the observable, and you can't react to it anymore, because you can't really just react to data. I mean, there is nothing that will automatically let you know when something's added to an array. There's no way to do anything in a reactive manner. Now, that's not to say you can't. You absolutely can, because you don't have to use this declarative approach. You can do everything with async await, and you can be 100% successful. But I just wanted to show another approach where you could really take advantage of these streams throughout your application.
Yep. Are there any other questions? So for a state management, whether we can use the subject or behavior subject?
Absolutely. You can people use RxJS as their state management solution. So if you don't want to go to NGRX or some other kind of state management tool because your product team isn't wanting to attack that, or your project just simply doesn't require it, you can use RxJS as your state management. One of the things that I didn't cover, because I only had 45 minutes, is that you can also add one of the operators, and it will then retain the data for you. I'm not explaining that very well, but basically, the first time it executes an HTTP request, for example, it will go get the data. If you use this additional operator, it will see that you already have the data, and it won't go get the data again. So it basically has a caching mechanism. So you can then cache the data and maintain your state through all of your observables. So you can definitely do that through your...
All right. Yeah, thanks for those answers. I hope we have picked most of the questions, but even if you have further questions, you can reach out to her using the Twitter handle that we will be sharing. And feel free to post us the question after the session so that we can get the right answers for you. Considering the time, let me share my screen. Yep. If there are no more questions, hope everyone must have enjoyed this session, and thanks for taking time to join even during your busy schedule. We have a small digitalized token of appreciation for joining us today and sharing your knowledge with us. I know it's too early there. Thanks for accepting the invitation in short time, and we will be sharing this in our social mediums as well. Hope to have you in our future conferences and meetups. Thanks for joining again, Deborah. Yep.
Thank you.
Yep. All right. Thanks everyone for joining. As the next step for this event, we have a virtual party, right? I'm just kidding. Yes, it's a Kahoot. We have set of questions prepared on RxJS. So it will be presented by our ngsrilanka lead for this year. Unfortunately, we couldn't have the conference this year, but we will be running few meetups this month and also in the coming months, and then we will have a event coming in the next year. So Aska, he will be presenting the Kahoot session. So feel free to jump in and pick the right answers. So the right answers or the points will be based on two aspects, right? First is how fast you answer in the questions. The second is, whether it's the right answer or not. So make sure you are giving the right answers, and also make sure you are, answering it in the right time. And there will be a bit of delay because we are live streaming it through StreamYard. There will be a bit of delay in showing the question. So we have allocated enough time to pick the right answer. Hope you will pick the right answers. And there will be one winner we will be choosing, and then we will be giving out the ngsrilanka t-shirt for the winners. I know we haven't given the prize for the winners who won the quiz. We will be sending out them soon. Thanks, Askar. Over to you. Askar, you are muted.
Okay, sorry for that. So I think Saji explained everything to you. So after a fruitful session, so let's check your knowledge on RxJS. So you can quickly join to the game with this using the pin game pin. So again, make sure to use your the correct name. So we will be picking a one winner. So make sure we can reach out to you via Facebook.
Aska, is there an issue? Prayer limit is reached? Something like that?
Okay, it says yeah, the limit is reached.
Hello, Aska. Can you hear me? All right. I think we are facing some trouble with the Kahoot. I know we are doing it for the first time. Probably there might be some settings that we missed to apply. Aska, is everything okay from your side, or are we good to go with the Kahoot? Or
I think Saji, we have to skip the Kahoot. I think we have some limitations
all right.
here that we have
Yeah.
to say.
Okay.
Maybe,
I
yeah.
know. All right. Okay. I think we are doing it for the first time after a long time, right? So we need to make sure that some of the things need to be sorted out in terms of getting the license for StreamYard and also for the Kahoot. I hope you all enjoyed the session. I think we are right on time. Exactly 2 minutes more. Yes, it's time to wrap up the meetup for today. Thanks everyone for joining. There have been a lot of effort behind the scenes, right? So I would like to thank Siva for living the live stream. He has done tremendous effort in making this live stream available to everyone. Thanks, Siva, for that, and Aska for the Kahoot. Even though we couldn't do it, I know you have made some time to prepare the questions. Thanks for that, and we will be sharing the Kahoot or the questions on our page so that you can go through. And Kushtanta and Milakshan for doing the designs. I know within short time we were able to come up with a lot of designs, and Saif and Mithushan for doing the social media updates and getting the questions from the audience. yes, we are a pool of team who is doing a lot of effort behind the scenes, right? Thanks everyone, and thanks extended team. There are a lot of members in the team who were, committed to running this event. Thanks everyone for the great support. If you have any feedback, please reach out to us on the Facebook community page, or you can reach out to anyone except me. So they are the ones who is driving this event entirely throughout this year, and look forward to meet you all in the coming months physically, and yes, physically soon. And we will keep you posted with the next speaker, with the new host for the next meetup. Thanks again, and stay safe. Thanks, guys.
Thanks, you guys.